Alright you guys, here's what we're going to do. Come on back, check this problem with me here. What I've got for you is a direct variation equation. I tell you that R varies directly as S. I'll tell you right in the problem what kind of variation is. You'll just then need to be able to write the appropriate function. So knowing that R varies directly as X, you should then be able to write this function. R varies directly as X. That means that R is equal to K times S. R varies directly as S. R equals KS, right? That's my direct variation formula for this particular problem. Now what I notice is that I'm given an initial value of R and an initial value of S. I'm asked to find R when S changes to a -6. This is my R1, S1. This is my R2, S2. So what I can do is go ahead and say, well, that means that K is equal to R divided by S. And since I'm given 2 points, that means that I can do R1 over S1 is equal to R2 over S2. And this will be the formula that I'll use, our second method from the previous video, for going ahead and solving for the unknown. So let's go ahead and start plugging stuff in. Bring this guy right up here. And here's what I know. I know that my initial value of R is -20, so -20. My initial value of S is 4, so divided by 4. That's all going to be equal to R2. I am not given R2, I'm asked to find R2, so I'll just leave that R2 value in there. And I'm asked to find R2 when S has changed to a -6. So I'll put a -6 down here, and this one's, it's pretty easy algebra. You're asked to solve for R2, I'm dividing by a -6, so multiply that -6 to the other side. R2 is equal to -20 over 4 multiplied by a -6. That means that R2 is equal to a -5 times a -6, which means I get R2 is equal to 30. Again, you should recognize this guy from up above. This is when we solve our direct variation equation and then set those two guys equal to each other because K is a constant. It's always the same. Doesn't matter what the R and S value is, it has to come out to this certain value of K. So we just set those guys equal to each other. You'll recognize that from above. We just used X and Y's in the example I gave you above, but here it's R's and S's. Doesn't matter what the variable is. You can make the variable anything you want to. Sometimes we even use Greek letters. Like, it doesn't matter what the variables are. So R1 over S1 equals R2 over S2. Plug and chug. All right, these are great examples of plug and chug problems as long as you know what the direct variation formula is. Head on over to the next page of notes, guys. We'll take a look at the next type of variation function, and I'll meet you guys there.